Most of the time, visual effects is about putting something into a shot or taking something out. And today we're going to take a look at how we can use 3D camera tracking to remove something on a ground plane. We're going to learn how to paint this out, and what's great about this technique is it automatically adjusts to the lighting of each frame, and even if there's motion blur, because you're always painting or cloning from the same frame you're working from. Just so you know, this technique can also be used to clean plate all kinds of objects if you have geometry that matches those things. So if you have a car, if you have geometry of a building, you can use that to apply the same kind of paint fixes and removals to those kinds of objects. So let's dig right on in and see how all this comes together. So the first step in this process is we need to actually camera track the scene. So we have a shot here. It's part of the Blackmagic tutorial footage you can get with the Fusion book and download. And the first thing you have to do when you are going to camera track is get rid of anything that is moving independent of the film set. The camera tracking, the photogrammetry, relies on the fact that things closer to the camera move faster than things further back. And the problem is if you have pesky things like actors in your shot that are moving independent of the set, they're going to confuse the tracker. So we have to mask out anything with independent motion. Now in this shot, that's going to be the three actors and the dinghy that they're pulling up, and the water itself, because obviously the water is not glued to the set. The waves are moving frame to frame. So we need to mask out the movement of the water, keep the headland here, keep the foreground sand. And what we've done is, ahead of time, because I didn't want to go through any tedious rotoscoping with you, I've gone ahead and we've started with a roto of the headland, we've added a roto of the beach, we've cut away Pirate 1, and we've cut away Pirate 2. And we didn't worry too much about the girl here. She's on for such a short amount of time that she probably won't throw the track. If we had to, we could go ahead and mask her out as well. What we'll do now is we'll add a camera tracker node. And of course, we need to feed this mask in. You'll see that camera tracker 1 has a track mask input. So we'll go ahead and connect that in there. And I'm going to select it and press 2 to load it in viewer 2. First thing I want to do is make sure that it's actually tracking the correct places. That, for example, I don't have my mats inverted or something like that. And so we can go in here and click Preview Track Locations. Might be a little hard to see them at first. And you can actually go in here to the second tab from the right and enable Darken Image, which will temporarily darken the image, not so that it will track any differently, just so you can see what it's identifying as trackable features. So going back to the first tab, I actually want to track more than this. And so if I lower the detection threshold and also lower the minimum feature separation, we can actually force it to track more points. All right. Now that we've got all our points ready to track, we just go ahead. I'm going to enable bidirectional tracking, so it will track from one direction and then track from the end backwards to get more tracking data. And we'll click Auto Track. Now you'll see that it's incorrectly tracked points around the girl here. We can just select those and hit the delete key to get rid of them. Just go through a few frames and get rid of any extra ones. Of course, if we'd rotated her, we wouldn't have to do this, but I was a bit lazy. Any of these false tracks will potentially throw the 3D solve. So the more we can get rid of, the better off we're going to be in getting an accurate solve of the shot. Most of these will probably get rejected by the tracker anyway, but we'll just kill off some while we can, just to make sure we don't get anything we don't want. All right, we could go through and look at some others, but we should now have enough tracking data to complete the shot. Now that we have the shot tracked, it's time to move on to the camera solve. So we click over to the next tab along in the camera tracker, First thing we want to choose is the kind of camera we're working with. In this case, it is the Blackmagic Ursa 4K production 16 by 9. Now, this is really important. You need to know what the film gate is so that it knows what size of sensor it should be solving for. The other important piece of information here is the focal length. And in this case, the focal length of the zoom lens that we had was 12.65. So we'll type that in. These two pieces of information are fairly critical. Fusion's camera tracker will try to guess if it doesn't have the correct focal length, but if you're not in the ballpark, you're probably going to have a hard time getting a good solve. So make sure when you're shooting stuff on set, you make note of what the focal length is and what the film gate setting is. And that may vary in the camera because you may be shooting 16 by 9 or you may be shooting with the full aspect of the sensor. And with that done, we go over to the next tab, which is the Solve tab, and we just click Solve. So what's happening here is that the camera tracker is taking all of those point tracks and it's calculating a virtual model of the 3D world that best matches the data. When it's done, we get this thing called the average solve error in pixels. And what that's telling you is based on the model it came up with, if it was trying to reproject and estimate the point positions from the model, how close would it be to correctly guessing the location of the points? In other words, how accurate is the model it came up with in predicting the location of the points? And right now, mine says it's 0.7487 pixels on average in error. That means on average, when it reprojects the points back into the world, the model predicts it within 0.75 of a pixel in accuracy. Now, that's pretty good, but I want to try and get a little better. And so the way we do this is we can scrub through. And if you look here, you've got a minimum track error and a maximum solve error. If I bring those down, you'll see points turning yellow. And if they turn yellow, it indicates that they would not satisfy that amount of solve error. So obviously, if I bring it down to 0, none of the points are going to accurately come within 0 pixels of being off. So I'll back this up a little bit. And what I want is to get rid of the worst offenders without losing too much data. I want a good representation of data from the foreground right through to the background. And so I can see that even at the original value, I'll get rid of quite a few points, but keep a decent amount of the data. I can also adjust the max track error as well. This is the maximum that they can be off at any frame. This is on average how many pixels off they can be, and obviously 0.164 is pretty good. So we select tracks satisfying the filters, and then we delete those tracks. And that should get rid of any points that may have thrown the data off in the first place. And now when we rerun the solve, our 0.75 goes down all the way to 0.375. And that's pretty good. It's highly likely that that is within any kind of tolerance that we need to do the work we want to do. Okay, we need to tell Fusion which way is up. It doesn't know if the camera was on its side, upside down, or whatever. And so we need to actually tell it where the ground is. So if we go to the next tab along, we have something called 3D Scene Transform options here. Right now it's set to align. We want to set it to unaligned so that we can make adjustments. And now let's scrub through and find right at the beginning where we can see a lot of the beach. And we're going to select a whole bunch of points by shift clicking and dragging. We want points all the way across the beach at different places because the more we can set, the more level we can make our ground plane. So I've selected all these points here, and now I can go to the orientation and choose Set from Selection. Now I can also pick a single point to be my origin. So let's say that we want to clean away this offensive blemish and everything around it. I can go ahead and select this point, and I'll say that's the center of my universe. That's 0, 0, 0 in my world. So I'll select that and just click Origin, set from selection. And with that, we're done. Now we can just click Export, and Fusion creates a whole 3D scene representing our world. Let me pull that down. And if I simply select the Merge 3D and press 1 to load it into my left viewer, I can now see how we did. So you can see something looks wrong. Our ground plane isn't actually aligned to the real flat plane of the 3D world. And that's a telltale sign that we missed something. Let's just delete these nodes here. Start over. If we go back to the camera tracker, we left the 3D transform set to unaligned. Let's go ahead and change that back to aligned. And now if we create, select the camera tracker and click Export, it'll create the new universe. We'll select the Merge 3D, press 1, and what you should find is if you option middle mouse drag, that the points on the ground do in fact line up with the 3D ground plane, and we're ready to go. So the plan here is we're going to create a plane. Think of it like a tablecloth that we're going to lay on the sand. And then we can paint fixes like remove patches or whatever, remove some of those divots, and then reproject the result back on a plane. Now, this sounds fantastic, and it actually works pretty well. The catch is, if you're coming from Nuke, you might think to go to the renderer and change that to OpenGL UV renderer to render out the surface of the blanket that we're laying out. Now, that would be very sensible and wise. Unfortunately, this thing doesn't really work. It's kind of glitchy and buggy. So we're going to build a custom solution for the problem. And so the first thing we'll do is create another camera, camera 3D, and we will leave it set as it is. And what we're going to do is attach a constant to it, which is called a background node. Connect that in. And if we look at this camera, let's go ahead and load it into the merge. Zoom out a little bit as our camera. And I'm going to rotate it so it's pointing down towards the ground. So with the camera selected, make sure, by the way, the original camera remains locked until you absolutely need to change it so you don't accidentally move it and wreck your tracking data. So here we are in the camera I just created, and I'm going to rotate it downwards, which will be an X. So I'll set it to an X of -90. And I'll just drag it upwards off the ground like so. And now because I added that image plane, I can adjust the depth of the image plane, and you'll see it appear. Let me just scrub it here. See it appear, and I could sort of dial it in there, but I'll create an expression to link it to the height of the camera. And all we need to do that is right-click, choose Expression, drag the plus up to the Transform section, and then we want to connect it to Translate Y. So I'll hover over Translate Y and release. And now, no matter what I do, it's always going to be lined up with the camera, which is perfect. Now, we want the original camera to project onto it. So we need to add replace material. So by adding the replace material, it's actually going to receive the projection of the original camera of the scene. So we head over to the original camera, we go to its projection tab, and we enable camera projection. We have to actually unlock it to make the change, enable camera projection. And while we're in here, let's turn off the image plane for that camera so we're not seeing the additional projection of the back here. We don't need that. So we're going to turn that off, and then we'll lock the camera again. Now, if we right-click and choose 3D options, lighting, let's turn off our point cloud. I'll just select and press Control-P for pass-through. I click away. You can now see that the background here is picking up the projection of the main 3D camera. And if we zoom in here, in fact, let's just do that. Watch what happens as I scrub through. Because it's locked in the scene at a specific location, it's always projecting the same bit of sand no matter where we are in the shot. So you'll see the geography, the location of this blanket we laid down remains the same even as the scene camera moves. And the beauty of that is we can now paint things out on the surface of it, and they will automatically be applied across time. So we can make clone paint strokes at, say, frame 12, and even at frame 20, it will still be cloning from whatever pixels at frame 20 are in the clone source location. So that means if there's motion blur, or if there's any change in shadow or lighting, our clone will still be cloning from the same frame and will pick up any of those changes automatically. So let's stop here, and in the next step, we'll actually do the painting. Before we actually paint, let's make sure we get the best position. So I'm going to select our camera, and what we want, because we have a limited number of pixels to render out here, is we want to get the tightest amount of space in this blanket as possible so that it only covers the area we want to paint and no more. So I'm going to zoom out a little bit, and I can adjust the size of the blanket, the amount it covers, just by dragging up and down. And then I can move the camera left and right to position it over the part of the image that I want to adjust. So let's just say it's this part of the sand that we want to clone out. We'll just clone out this area here. We need some area to clone too, so we don't want to crop too tightly by zooming in too close to the ground, because then we'll have no sand to grab as a source for our clone. Let's just pick something like that for this example. And we're just going to pretend we're removing this guy and this guy right here. So if we go to the camera renderer over here, I'll press 2 to load it in the viewer, we need to enable lighting. Let me just turn off the ground plane here to see things better. And in the camera, we need to choose for it to render from our new 3D2 camera. So we change the camera from default to 3D2, and it's now rendering from up above. And there it is. It's rendering out our patch of blanket, as it were, that we've laid out on the ground. All right, you know what? Let's actually look at painting out just this section here. So I'll add a paint node, connect it to our render. When I use single stroke and clone, and you'll see that the stroke will be across all frames, which is what we want. Make it nice and big. And let's just choose a clone offset source that's nice and far away. And now we're tidying up our beach a little bit. Now, I'm not going to do a great job here. You'll see it's yellowing a little bit because I should really be using some transparency offsets and things like that. But you do have to be careful with these because over time you can end up with problems as the clone sources disappear. So let's just take a look at how that's going right now. You'll see as I move to other frames, it continually clones from other locations, and all is well. Now I haven't done a great clone job here. You can see there's all kinds of duplicates everywhere that don't look great. But for the most of the shot, we are in fact cloning our area. Now I need to have a little polygon here because I need to decide which area I want to replace. So I'll make a little shape here, and I can say that's the area of the patch that I want to replace. There's my polygon. I'll add some softness for blend. And we'll just use a matte control to pipe that in Now, Alter Option, click onto the Mac controls so you can select foreground, otherwise the polygon will automatically connect to the mask input. But now you'll see I have, whoops, forgot to set combine to combine alpha. I'll turn off my checker underlay. So there we go. We have that combined into the alpha channel. Final step is to re-render it back out. So now that we have our painted texture, we need to reapply it to that camera grid, that camera plane, that bit of blanket we created. And that's coming out over here at the replace material. So we'll add another replace material. And we'll connect it to the output of the original. So we're doing another material replace, but this time we want to replace it with the material that we just created coming out of the Mac control here. Now that we've done that, we need to merge it back into a scene with the original camera so we can use the original camera. So let's grab that, pop it into this Merge 3D. So we now have our camera plane with the replaced painted version of the texture, and we've got the original camera merged in. And now we can add another renderer. And in this renderer, we choose to render with the original camera. And lo and behold, we now have our little piece of blanket rendered out with the painted version. We can see that because if I select the paint and press Control P, we can see the difference. Those are the bits we painted out. And now, if we take that render and pre-multiply the alpha that we added, alpha multiply, bang, we have just our little patch. And if we go all the way back to the original source footage and kiss to create a new merge, the final merge here will include our patch. So let's have a look. If we select our paint over here and press Control P for disable, we can see what it's painting out. But the beauty of it is, whoops, I shouldn't be accidentally adding paint. Let me deselect paint. The beauty of this is that it works all across time. We didn't have to paint every single frame or come up with some fancy way of clean plating and match moving. The paint pretty much holds up the whole way through. Now, if it doesn't, we can always go back in and readjust the paint, but it all works pretty well. Let's select the paint, Control P to disable, Control P to enable, and you can see our patch. It's not perfect because I was pretty nasty with my paint work. Should have used a Wacom and some more subtle blending, but it does the job. And the final step is not an important one for the shot, but it's an important one when 2 days later the client wants to come back and make changes, and that is just to clean things up a bit. So we have a point cloud here we don't really need, so I'll push that off to the side of the plate. Likewise with the ground plane, we don't need that. So they can go off over here. We need the background and the new camera. Replace material. We'll select those and underlay them. And we can rename that to projected plane. And just click OK to the rest of these renames. There's a meteor in. That needs no explanation, but we will Alter Option drag to add some elbows here for organization's sake. Then we have the original scene here. This can kind of go out of the way now. The all-important media out needs to obviously be connected to our final merge, like so. The camera tracker itself can stay over here, connected to the original source footage. And this is our paint work. We need to re-enable that, of course. We'll select all of this section, add the underlay, and we will call this clean plate. Click OK to the rest. All right, so now when we have to come back and make changes, it's a whole lot easier. Maybe we'll add one more down here. Underlay. We'll call it final patch render. And there we have it. A very simple overall way to eliminate part of your ground by doing a 3D track and then rendering out the result. All right, so let's take a look at the before and after. You'll see this is the area that we did the replace on. Let's watch. Like I said, apart from my lousy paint work, it actually holds together pretty well. We'd also want to add a little bit of sharpening just to bring back some of the definition that was lost in the process of stretching this out and re-rendering it back. Hope you guys enjoyed this impossible shot, and stay tuned for more in the coming weeks.